Hi, my name is John Kim, and you guys all know who I am. This is usually for Ventura High School students, but it's not just for Ventura High School. It's Buona High School as well as any school that uses this book right over here. It's called Mathematics, Advanced Mathematics by Brown, right there. This is usually reserved for honors Algebra 2 students. So for those of you that are taking honors Algebra 2 and you kind of need to understand how to do functions and you're using this book, it might be a good reference. Anyways, so here's chapter 4, section 1. This is I had a lot of requests from my students who wanted to, kind of getting confused about this, so I decided to create a lecture on chapter 4, section 1. There it is right there, for honors Algebra 2 by Brown, and it starts on page 122 problems. The topics that we're going to be covering today are mapping process, the domain, equation versus graphing, the range of the equation versus graphing, the vertical line test, select the questions, number 5, 7, 10C, 11A, 12C, 18, 20, and 21. These are the numbers that, the questions that we're going to be covering for these problems. Okay, right here somewhere. Okay, so let's get started. I literally spent about 30 minutes going over the preview of this, what do you call it? The lecture on this one. So let's look at the mapping process, see how it's supposed to work out. Okay, guys? So how does the mapping process actually work? Here's your domain, the domain, and then it goes to your range of values that comes out. The domain is your x, your range is your y. So you look at domain or range. Sometimes you go dx and then you go range of y. Also you could do, this is called your input, that's your output. And also you could do a mapping process this way. You can go from here. Let's say this is function f, that's your domain, and that's your range or domain, which is your x, and the range of values that comes out. You could also look at it one other way. You input an x, you go through this function, this black box right over here, whatever it says to crank out, and then you get a f of x value. Okay, and that's your y value. So look at the f of x as a y value, and look at your input as x. So in other words, let's do a simple example. F of 3 equals 2 means what? Means when x equals 3, there's your x value right there. That means your y value, then your y value has to equal 2. Or in the coordinate system, it's going to be 3, 2. Okay. So you can look at it many different ways. The domain range, x, y, input, output. And the mapping process as well. Or you can look at it as a box. You input an x, that's your I right there. You get an output. This output must be unique. If it's not unique, it's not a function. So if you put in a 2, you get a 5 or a 7, then it is not a function. Okay. So let's get domain and range for equation versus graph. Okay, so if a function looks something like this, I'm going to use another tape. I'm going to use maybe this one. Oops, let me go to my Logitech right here. So if I have a function like this, graphically, then these are my domain that goes from here all the way down. So it's going to be like this all the way out because it's going out this way, right? So the domain is x is greater than or equal to 0 or just greater than 0. And let's say my y value is here, like this. Whatever this is, let's say it's 1. Y is greater than 1. That's your domain and that's your range. Okay. So that's how you do domain ranges, and that was on page 120 as well. And example 2 gives you a pretty good problem on example. This is like kind of example 2 on page 120. Let's look at another problem mathematically. Let's see what it looks like. Let's say you have a function like this. Y is equal to g of x this time instead of f of x. It's equal to 1 over x minus 7. This is example 1, okay? What can be the value of x? What cannot be the value of x? That is the question right over here. So it says we want the domain of this function g. X cannot equal 7 or all real numbers. So the way you write that is all real. That's how you denote all real numbers except 7. There's your answer. There's another question I want you to do. It's kind of like example B. This is a little bit more difficult problem. That's part A. Let's do part B. The part B is h of r is equal to square root of 1 minus r squared. I hope you see that. It's h of r is equal to 1 square root of 1 minus r squared. This is a little bit tricky. And we're going to do another similar problem like this. You set the inside the radical cannot be less than 0. In other words, 1 minus r squared has to be greater than or equal to 0. Make sure you get the equation set up correctly, okay? 1 minus r squared has to be greater than or equal to 0 because the inside of the radical cannot be negative. You heard about imaginary numbers yet? I'm not sure if you looked at imaginary numbers yet or not, but square root of a negative number is an imaginary number. Square root of 1 minus r squared, that's the inside, has to be greater than or equal to 0. Move the r squared to the right side by adding r squared to both sides. R squared is less than or equal to 1. Just take the square root. When you take the square root of r squared, it becomes the absolute value of r. And the square root of 1 is 1. This is a new little thing that you're going to learn. When you take the square root of r squared, it becomes absolute value. Square root of 1 is obviously 1, because 1 times 1 is 1. This means r is going to be between negative 1 and 1. And that's your domain. Okay? So your domain is a set of values of r such that it's going to be bigger than negative 1, but smaller than 1. So what's a vertical line test? It's pretty simple. When you have a function, something like this, and you pass any vertical line here, notice that there's only one point that passes through it. Here, notice there's only one point that passes through it. Here, you notice there's 3 points that passes through it. It must only pass through one point, so therefore this is not a function. It's a relation. They call this a relation, but not a function. Okay. So that's page 2. Let's do some more. So let's do problem number 5. Number 5 is pretty simple. Here's what it looks like. Something like this. It says, the question says, tell whether the graph is graph of a function. If it is, the domain and range of function. Obviously, boom, vertical line test. No, it is not a function. 7. Explain why x squared plus y squared equals 1 does not define as a function of x. Let's look at this one right here. If you look at this function, x squared plus y squared equals 1, how do we, you don't really know if it's a function or not, but since you're taking Algebra 2, I'm pretty sure you took geometry last year. Honors geometry, that is. So let's look at this. You should have covered this a little bit last year. X squared plus y squared equals 1. It's on your SAT as well. And you'll see this equation over and over again. This is an equation of a circle with radius equals 1, center equals 0. One more time. Center equals 0, 0. That's your origin. And your radius is equal to 1. So here it is. 1, negative 1, 1, negative 1. And there's a circle. And here's 1. And we know that it's not a what do you call it? A function because it passes through 2 points right here. Well, graphically, you notice that it's not a function. How do you show that it's not a function mathematically? Well, if I solve for y, I have to move the x squared to the right side. To move the x squared, I have to subtract x squared. So y squared is equal to 1 minus x squared. I take the square root of the left side, square root of the right side. Square root of y squared is absolute value of y is equal to square root of 1 minus x squared. There it is right there. But absolute value of y means y is equal to square root of 1 minus x squared, or y is equal to negative 1 minus x squared. It could be plus or minus. This equation right over here is the top portion. So if you restrict it to the top portion, then it's a function. And obviously, because of this minus right there, of this minus, the minus on the outside makes it reflect about the x-axis. Okay? There's a reflection about the x-axis to make it, and you'll learn about that in 4.2 or 4.3. I think it's 4.3. You'll learn about this in 4.3. Okay, the negative on the outside. Okay, that's it. Let's look at so this is not a function. How about 10c? It says give the domain of each function. So what we do is we look at the bottom line over here. We can factor out an h. I'm sorry, you can factor out a t, excuse me. It's going to be t squared minus 9. T squared minus 9 is a difference of squares, which is also factorable. So that becomes t times t plus 3 times t minus 3. The thing that you have to look at the domain of this function is that the denominator cannot equal 0. This is really, really important in finding the domain. So we're restricting the value of t. Excuse me. So if it's t cubed minus 9t, it factors to t times t plus 3, t minus 3. So the domain is all real numbers except t cannot equal 0, 3, and negative 3. And that's your domain. Okay? Next question. Okay, let's look at number 11. Y equals f of x. Absolute value of that. It says give the domain, the range, and the zeros of the function. Well, before we graph this, let's graph something a little bit more easier. Let's graph y equals x. What does that look like? There it is right there. It's a 45-degree line. I asked one of my students, what kind of line is that? And one of my students says, a straight line. And I said, really? That's a very good observation. A straight line. All lines are straight. Never mind. Okay, talking to myself. We want the absolute value of x. What happens here is the absolute value, whenever the y value is negative, reflects it about the x-axis. So this point right here, it goes away and it turns into this v. And so there it is. Absolute value, v value. Okay, that's a good way to memorize this, guys. This is a parent function. It comes out quite a bit, and you'll see this at least 100 more times. There's a lot of these that you'll see over and over again. So we graphed it. Give the domain. The domain is what can be the value of x, what cannot be the value of x. Notice x can go everywhere here, 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 here. So the domain is all real numbers. How about the range of values? Well, if you look at the range of values that comes out, let's use blue this time. It can go here, 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 and here. So it's going to be the values going up. So if you collapse it this way, along the y-axis, it goes from 0 on up to infinity. It's y is greater than or equal to 0. Okay, that's your range of value that comes out. And what is the 0? It happens when x equals 0, just by looking at the graph. Inspection of the graph tells you that it's going to happen when x equals 0. Okay, number 12. C. Oh, that's a little tricky problem. I put a little tricky problem. We did something like this earlier. Let's see what happens here at this stage. Okay, so we're going to do this. We'll attack this problem 2 different ways, and I'm going to show you how it works both ways so that you can just kind of see it working. First of all, as we said earlier from the previous example, we set the inside of that is 9 minus t squared, set it greater than or equal to 0. Move the t squared to the right side by adding t squared. T squared is less than or equal to 9. Take the square root of both sides now. And you get absolute value of t is less than square root of 9 is 3. Means, what does this mean? T is less than or equal to 3. That means what do you call it? T is between -3 and 3. Got it? That's your domain. Okay, so what are the range of values that comes out? I think I might have given a mishint on maybe one of my students because I just figured it out and it's not all real numbers or positive numbers for the range. But anyways, let's try to graph this. Call this y. That's your y value right there, h of t. So y is equal to square root of 9 minus t squared. Square both sides. You got y squared is equal to 9 minus t squared. Move it over. T squared plus y squared is equal to 9. Wow, you've seen this equation before, haven't you? It's an equation of a circle, except your t is your x direction. Your y is your y direction. Of course, t is your x and y left and right. And y is going to be up and down. It's going to be up 3, down 3. Left 3 and right 3. And there's your circle right there. But remember, at the very beginning, the function is positive. There's a restriction. There it is right there. So the domain, that's your t value. Notice that it's between -3 and +3, which makes perfect sense. But what about your range of values that comes out? The range of values that comes out is y is between 0 and 3. I think I said to my students y is greater than equal to 0, but it's also smaller than equal to 3. The reason why that happens is because when t is 0, my maximum value is going to be 3. When t is 0 in the x direction, my y value is going to be 3. When x is 3, 3 squared, 9 minus 3 squared is 0, square root 0 is 0. So there it is. Okay, so the domain is here, and the range of values that comes out is here, due to this restriction, the positive portion. Okay, next question. This is a little bit difficult question. This is, I know you've never seen something like this, or maybe you have. I'm not sure if you have or not. From previous chapters, if you actually seen something like this before. I decided to do this problem because it's a little bit special. It's a little bit difficult. The g of u function is equal to u minus 1. If u is less than 0, u squared minus 2u minus 3. If u is between 0 and 3, and 0 if u is greater than 3. These are called piecewise functions. Okay. The reason why they're called piecewise function is because when u is less than 0, that's your domain, your input. When u is less than 0, you use the top piece, u minus 1. But if u is between 0 and 3, then you use the middle piece. If u is greater than 3, you use the bottom piece. And that's why they're called piecewise function. Use the top piece, otherwise you use the middle piece, otherwise you use the bottom piece. And these are your domains, and this is the range of output that comes out. Okay? So let's try to work this out here. When u is less than 0, that right there, it's going to use this piece. y is equal to u minus 1. It's going to start off on -1, and then it's going to go 45 degrees. And we're going to restrict it to this bottom piece right there. So at -1, it's going to go this way. Do you see how we did this? Otherwise, when u is between 0 and 3, it's u. I'm going to factor that u minus 3 times u plus 1. Okay. So when I factor this, u minus 3 and u plus 1, it's going to look something like this. It starts at 3 and then ends at -1. It's going to look something like this. So it's probably going to end up here. I'm going to use a blue. So I'm going to use this piece right there. So it's going to fill it up because it's equal to it, fills it up, and then it goes like this. And that's 3. Whoops. I have to stop right there, don't I? Because it's equal to 3. So there it is right there. And then when u is greater than 0, when u is greater than 3, sorry, my y is going to equal 0. What does that look like? It's a horizontal line, right? With starting at 3. An open circle and goes this way. So it has an open circle which was filled by the blue and goes this way. So that's what it looks like. This piecewise function to the top piece, given the restrictions for x, which is our u value, use the middle piece when u is between 0 and 3 or x is between 0 and 3. And then if x or u is greater than 3, use the bottom piece. And thus you have your first piecewise function. You're going to see a lot of piecewise functions in 11th grade and 12th grade too as well. Okay. I just like to do 2 problems right here. Number 20, it's a cute little problem, as well as 21. So let's take a look at them and work them out. Do you remember this formula in honors geometry or geometry? 9th grade, usually most students take it 9th grade. It says the sum of the angles of a triangle. Sum of the angles is equal to the number of sides minus 2 times 180 degrees. So if n equals 3, n equals 3 sides, what's that, guys? A triangle, right? 3 sides, triangle, it has to be a triangle. It has to be 3 minus 2 times 180 is equal to 180 degrees. And we all know that the area, or not the area, the angle of the sum of the sides of a triangle is 180 degrees. What if n equals 4? Then that means it's going to be 2 times 180, which is equal to 360 degrees. A 4-sided figure is called a quadrilateral, excuse me. 4-sided figure is called a quadrilateral, and it has 360 degrees, of course. Let's say n equals 7. It's going to be 7 minus 2, which is 5, times 180. 180 times 5 is 180, 360, 540, 720, 900. 900 degrees. So n equals 7, that's a heptagon, right? 7-sided figure is called a heptagon, and it has 900 degrees. How cool is that? Nah, not so cool. Okay, anyway, so here we go. So give the meaning of this formula, I give the meaning of that formula. S is a function of, is S a function of n? Yes, of course. Whenever you plug in the value for n, it's going to give you S, or the sum of the angles. The domain, what is the domain? What can n equal? What can n not equal? That is the question. N can equal 2. 2 minus 2 is 0 times 180 is 0. Does that make sense? Can you have a 2-sided figure? Of course not. So n has to be greater than or equal to 3. That's your domain. And of course, 3 sides is triangle, and then quadrilateral, then pentagon, hexagon, heptagon, octagon, nonagon, decagon, etc. etc., etc. Last, we found the domain. What's the range of value that comes out? The range of value is equal to multiples of 180. Has to be 180. 180 times 2 is 360, times 3 is 540, times 4 is 720, times 4 is 5 is times 4 is 720, times 5 is 900, times 6 is 1080, times etc. Okay, guys. The last question is the greatest integer function. That was part of your homework as well. It might be on the test, so be careful. Okay. The greatest integer function assigns a number to each of the greatest integer less than or equal to the number. So, by definition, the greatest integer function is less than or equal to the largest integer of x. So let's do some examples. What's the largest integer of 3.7? It has to be less than or equal to 3.7. The largest integer is equal to 3. There it is. The largest integer of 4.2 is 4. The largest integer of 3.001 is 3. The largest integer value of negative 4.2. Think about this one, guys. This is tricky. It is not negative 4. It is going to be negative 5. Negative 5 is the largest integer that's less than or equal to 4.2. Okay. So how do we graph this? At 1/2, what's the largest integer of 1/2? 0. What's the largest integer of 0.2? 0. Largest integer of 0.7? Still 0. So it goes up to it, opens it up. At 1, it's going to turn to 1. What's its largest integer of 1.1? 1. How about 1.7? There it is. How about what's the largest integer of negative 0.5? It's negative 1. How about negative 0.7? Negative 1 again. Use the definition that we just gave you here. Okay? So it's going to be an open circle here. And then it's going to go down like this. Greatest integer function is also called a step function, guys. Okay? You'll see these step functions. I've seen step functions when I was in graduate school like crazy when I was doing math. So here's how we do it mathematically. I'm just going to angle it just right. Going to by equals button right over here. Go to math. Here's the numbers. Here it is right there. There's the integer function, number 5. Integer value of x. And so you have it. And let's set a window from negative 3 to 3. Negative 3 to 3. And then graph that out. Boom, there it is. Okay. You can also get rid of your x-axis going to Windows. Sorry. Let me see. Format. Is it table stat plot? No? No, it's not stat plot. It's format, I think. And I'm going to turn the axis off. Then graph it. So you can see the stepwise function. Step function going up like stairs. Okay. I'm going to go back to calculate. Sorry. Go to format. I'm going to turn on my axis again. Let me graph it one more time. And there it is right there. Okay. Good luck with your homework, guys. And thanks for watching.